we're going to talk about how to find the square root of a rational perfect square. So there's a couple things that you have to understand about square roots and rules of square roots, or rules of what we call radicals, to do this problem. So before we tackle this problem, I'd like to just talk about the square root rules. Okay, so the rules that you're going to need to understand for this one and maybe for other ones in this lesson, we're going to talk about the division rule and the multiplication rule. So the rule, I'm going to write it out as math terms, like with variables, but then we can do examples that go with it. So the first rule we'll talk about is the multiplication. So if I have two numbers multiplied by each other all underneath the square root, and when I draw my square roots, by the way, I kind of put a little, I call them a tail on the end, so I know where my square root ends. So basically this thing is saying if I have two numbers multiplied together under the same square root, the rules of square roots say I can separate them and take the square root of each individual number. So let's pretend, for example, I had the square root of 9 times 25. It doesn't even matter what 9 times 25 is, okay? I can break it apart and I can say that's the same as the square root of 9 times the square root of 25. Then I can evaluate. The square root of 9 is 3, the square root of 25 is 5, and I multiply together and I get my answer of 15. But this is the main rule that you want to understand as far as multiplication goes. Same rule applies for division. So if I'm looking at a problem, let's pick a different color. Let's do green. So say I had the square root, say I had the square root, the big square root of 36 over 49. Square root rules with when I'm dividing, if I have the big square root divided by a fraction, it says I can take this and I can break it up. So this would be the square root of 36 divided by the square root of 49, which I can then evaluate separately. Square root of 36 is 6, square root of 49 is 7. So the rule looks like this. This big square root of x over y, my fraction, is the same as the individual square root of the top divided by the individual square root of the bottom. So this would be my main rule that we're focusing on. Okay, so now if I go back to here, I can do my same problem. We'll do it in black. So I can rewrite this. This is going to be the same because it's a dividing of one big fraction. I'm going to split it up and I'm going to do the square root of the top individually. Divided by the square root of the bottom individually. Then I take the square root of 64. The square root of 64 is 8. The square root of 81 is 9. And this would be my final answer. It might help you also, if you're not confident in your square roots, to just make a list. So here I like to make my list if this is x and this is x squared. We got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We'll go up to 12 because that's as far as it's going to go on here. Is 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, and 144. I would suggest knowing up to like at least 15 off the top of your head, but the 1 through 12 is what you'll use the most. So that might help you as a quick reference. If you have any other questions, let me know.